Picture this. You're driving through Death Valley, California, in the scorching heat of summer. The asphalt is melting, the air shimmers like a mirage, and your car's thermometer reads 120 degrees Fahrenheit. Suddenly, you see something impossible, a lone figure running across this hellscape, not just surviving, but smiling. This isn't a hallucination. This is Dean Karnazes, and he's about to shatter everything you think you know about human limitations. While most of us struggle to run a single mile, Dean completed the Badwater Ultramarathon, a 135-mile race through Death Valley, and then kept running for another 215 miles, without stopping. But here's the truly mind-bending part. Dean isn't alone. There's a growing population of humans who possess what can only be described as supernatural endurance. Scientists are calling them ultrahumans, and their abilities are forcing us to rewrite the textbooks on human physiology. The story begins in 2006 when researchers at the University of Colorado first encountered Dean Karnazes in their laboratory. What they discovered defied medical explanation. After running at a steady pace for hours, Dean's blood showed almost no elevation in lactate levels, the burning compound that forces normal humans to stop. Dr. Michael Joyner, one of the world's leading exercise physiologists, described Dean's results as physiologically impossible. Yet there Dean stood, barely breathing hard, asking if they had a longer treadmill. But Dean wasn't an anomaly. In remote villages across the world, stories emerged of people with similar capabilities. The Tarahumara people of Mexico's Copper Canyon have been running distances of 100 to 200 miles as part of their daily culture for centuries. Ethiopian and Kenyan runners consistently dominate ultra-distance events with an ease that seems almost alien. These weren't just trained athletes. These were humans whose bodies operated under completely different rules. The first major breakthrough came when Dr. Yannis Pitsiladis from the University of Glasgow began studying elite Kenyan runners. Using advanced metabolic analysis, his team discovered something extraordinary. These runners' muscles contained up to 25% more mitochondria, the cellular powerhouses that convert oxygen into energy, than average humans. But that was just the beginning. The mitochondria themselves were different, more efficient, almost like they had been upgraded by some unknown biological process. Further investigation revealed even more shocking anomalies. Ultra-endurance athletes showed unusual patterns in their gene expression, particularly in genes controlling fat metabolism and oxygen utilization. Dr. Alejandro Lucia's research team in Spain found that some ultra-runners possessed rare genetic variants that allowed their bodies to burn fat as efficiently as most people burn simple sugars. Essentially, these humans had unlocked a completely different fuel system, one that provided virtually unlimited energy. The cardiac adaptations were equally mind-blowing. Using advanced imaging techniques, researchers discovered that ultra-endurance athletes developed heart chambers up to 40% larger than normal humans, with stroke volumes that would be considered pathological in anyone else. Their resting heart rates dropped as low as 28 beats per minute, barely detectable by standard medical equipment. Dr. Benjamin Levine at UT Southwestern described it as witnessing human evolution in real time. But the most intriguing discoveries were happening in neuroscience laboratories. Dr. Timothy Noakes at the University of Cape Town proposed a revolutionary theory, the central governor model. According to his research, the human brain possesses a built-in safety mechanism that forces us to stop exercising long before we reach our true physical limits. This neural brake protects us from literally running ourselves to death. But in ultra-endurance athletes, something extraordinary happens. This brake system appears to malfunction, or perhaps evolve. Brain scans of ultramarathon runners revealed unusual activity patterns in the anterior cingulate cortex and insula, regions responsible for pain perception and self-awareness. During extreme exertion, these areas showed decreased activity, effectively turning off the signals that would normally force a person to stop. Dr. Daniel Lieberman from Harvard described it as the brain learning to ignore its own protective mechanisms. Even more fascinating was the discovery of neuroplasticity changes. Ultra-endurance athletes showed increased gray matter density in areas associated with pain tolerance and emotional regulation. Their brains had literally rewired themselves to handle suffering in ways that would be impossible for normal humans. Some researchers began referring to it as evolved consciousness, a state where the mind transcends its biological programming. Recent studies have pushed these findings into even more extraordinary territory. In 2019, Dr. Courtney Kipps at University College London published research suggesting that some humans might possess what she termed metabolic immortality during exercise. These individuals could theoretically maintain steady-state exercise indefinitely, limited only by the need for sleep and nutrition. Their bodies had achieved something that shouldn't exist, a perfect balance between energy expenditure and regeneration. The genetic component became even more intriguing when researchers discovered that many ultra-endurance athletes shared specific DNA variations related to pain perception. The COMT gene, which controls dopamine breakdown in the brain, showed unusual patterns that correlated with increased pain tolerance and enhanced motivation during extreme physical stress. Some scientists began speculating about whether these variations represented evolutionary adaptations, humanity's next step forward. But perhaps the most shocking discovery came from studying the cellular aging process in ultra-endurance athletes. Dr. Larry Tucker's research team found that these individuals showed significantly longer telomeres, the protective caps on chromosomes associated with aging. Not only could they run impossible distances, but their bodies appeared to age at a dramatically slower rate than normal humans. Some ultrarunners in their 60s showed cellular ages equivalent to people in their 20s. The recovery capabilities were equally superhuman. While normal humans require days or weeks to recover from extreme exertion, ultra-endurance athletes showed complete physiological recovery within hours. Their inflammatory responses were muted, their tissue repair mechanisms accelerated, and their energy stores replenished at rates that seemed to violate basic biology. Dr. Stephen Seiler described observing healing processes that bordered on regenerative. These discoveries raised profound questions about human potential. If some individuals could naturally develop these capabilities, could they be induced in others? Early experiments with high-altitude training, specialized nutrition protocols, and even genetic therapy showed promising results. Some researchers began developing programs to unlock ultra-endurance capabilities in normal humans, though the ethical implications were staggering. The military applications were obvious and concerning. The U.S. Department of Defense began funding research into creating soldiers with enhanced endurance capabilities. Private companies started offering expensive training programs claiming to develop superhuman endurance. The line between natural human enhancement and artificial augmentation began to blur in ways that made many scientists uncomfortable. Recent case studies have documented even more extreme examples. Yannis Kouros, a Greek ultrarunner, once ran 1,023 miles in 6 days with minimal sleep. Dean Potter, before his death in a base-jumping accident, combined ultrarunning with extreme mountaineering in ways that seemed to defy both physics and human limitations. These individuals weren't just athletes. They represented something fundamentally different about human potential. The psychological profile studies revealed fascinating patterns. Ultra-endurance athletes scored differently on virtually every measure of pain tolerance, risk assessment, and reward processing. Their brains appeared to be wired for extremes in ways that made normal human behavior seem almost pathologically conservative. Dr. Richard Davidson's research suggested they might represent a distinct neurological phenotype, essentially a different type of human consciousness. As we stand at the threshold of understanding these capabilities, the implications are both thrilling and terrifying. Are we witnessing natural human evolution in action, or the emergence of a new subspecies? Could these abilities be developed through training, or are they fundamentally genetic? And perhaps most importantly, should we be trying to create more humans with these capabilities, or are we tampering with forces we don't fully understand? The answers to these questions will likely define the next chapter of human evolution. What we do know is that the limits we thought were absolute, the boundaries we believed defined human potential, are proving to be far more flexible than we ever imagined. These ultra-humans aren't just running impossible distances. They're running straight into a future where the very definition of human capability must be completely rewritten. The next time you struggle to run a single mile, remember, somewhere out there, a human is running through Death Valley with a smile on their face, carrying secrets in their DNA that could change everything we think we know about what it means to be human. The question isn't whether humans can transcend their limitations. It's whether we're ready for what comes next.